Okay, in this video we're going to start talking about some of the threats to biodiversity, and then there's one more video to come after this, so we're almost done. All right, so let's first talk extinction and extirpation threaten biodiversity. Now, that term extirpation, that's one that you're going to find in your textbook. You need to be familiar with it. Extinction is when you lose an entire species. So let's say elephants went extinct, so all species of elephants went extinct. But extirpation is when you don't lose the entire species. You might lose a population, or you might lose one subspecies of an overall species. So it's kind of a chunk of it, but it's not the whole entire species. So there's a difference there. So the Earth has experienced 5 mass extinctions, and you can see this chart here. You see as the chart goes up, it's charting the number of families living at the time. And they're talking about the families meaning in the taxonomic tree. So you've got, we're discovering all these species, and then you've got the first dip there, and then it goes up again. That's the first extinction, and then the Devonian extinction, the second one, and then you go to the Permo-Triassic extinction, which was kind of a double dip. You go one, and then it went up a little bit, and then the end of the Triassic extinction. And then we had the Cretaceous Tertiary extinction. So that was number 5. So you see those dips in the chart there, and then the bottom is how many millions of years ago. So 0 right there is present. Of course, this is copyrighted 2008, so a smidge behind the times. So in the past 440 million years, mass extinctions have eliminated at least 50% of all the species that we knew of during those times. We had dinosaurs go extinct at the end of the Cretaceous period about 65 million years ago, and that's the extinction, the mass extinction that most people talk about. But we had extinctions before that one, and we've learned that through fossil records and all that. Now, the question and with the rate of extinction, the question is not whether extinction occurs. We know it occurs, and we know it's a natural process because there's places where humans do not live, and the average background rate of extinction is that one species goes extinct every 10 years on average. Okay, so that's your background rate. It's a natural thing. It happens whether people are there or not. So it's not a question of whether extinction happens or not. We know it happens. The question actually should be, and is, how much has the rate of extinction been accelerated by human causes? Now, I'm not saying humans are directly a cause, but there are things that we have done that upset certain balances that do lead to reactions that cause issues. So in places where humans do live, the combined rate of extinction is 10,000 species and subspecies per year. So a much, much higher rate than that background rate. So we know for a fact that humans do have an impact on the rate of extinction. The current mass extinction is human caused. Okay, there is no doubt about that. There is scientific evidence that it is human caused. Now, during this era, our modern era, which is called the Quaternary period, we may lose more than half of all the species that currently exist that we know of today. Today's extinction event differs from others because, one, it is being caused by humans. The other extinctions happened before enough humans were on Earth for us to really have any kind of a major impact. Also, we are going to be the ones to suffer immensely because of it, and that, of course, is a lot to do with those ecosystem services that we talked about and those reasons for protecting biodiversity. The current global extinction rate is 100 to 1,000 times greater than the background rate. Okay, we discussed that background rate. This rate could actually increase tenfold in future decades if we don't do something to curb our impact on our environment pretty quickly here. And we're going to be talking about climate change and the issues that it has. And you can try and debate with me that climate change isn't happening, but it is happening. It is a scientific fact. We are going to spend some time talking about that, and that also has a major impact on extinctions. Now, talking about extinctions, this is a picture of the very first species that went extinct in North America, not in the world, but in North America. This is a picture of the great auk, A-U-K. And it was basically a water bird, kind of like a puffin. And they were so prevalent that basically they were found all along the shorelines. And so you get these whalers and these explorers, and these guys were just literally like coming up in boats and just grabbing the ox right out of the water, and they were eating their meat, and they were taking the down and using them to create food and stuff pillows and all that. They ate their eggs, and it was one of those things where there were so many of them that we never even thought they could go extinct, but there was no regulation, no way to protect them, and so we just kept taking and taking and taking until basically they declined past that critical point where they had just not enough of them to continue to bring that population up. And so they just plummeted and they went extinct. So you can see here, first species in North America to go extinct due to human activity. It was estimated to have numbered in the millions on the shores and islands of Northern Europe and North America just 2 centuries ago. But by 1845, it was extinct. The last one was actually seen in 1844. So that was the first species in North America to go extinct. Here are other extinctions, all caused by humans. You can take a look at this and look through them, look some of them up if you want. The golden toad there, that one in Costa Rica, they talk about the cloud forest one. That's actually in your book, I think, so you can read a story about that. Okay, but the idea here is that it's not just extinction. That's not the only threat to biodiversity. There's a lot more to it, and there's a lot more to protecting biodiversity than just saying, well, we just need to stop species from going extinct. There are actually very important reasons for it, and we have some interesting examples to discuss here. But biodiversity loss, again, more than extinction. Population declines and shrinking wild habitat are leading to the loss of genetic, ecosystem, and species diversity. And this is bad for everyone, especially humans. So if you're talking to someone, and you might be talking to your buddy over a beer or something, you say, yeah, I just learned about this in class. It's really important to stop this extinction. And they might say, why? Well, here's a great example that you can talk about. And it has to do with vultures. Okay, so there are two species of vultures found over in India and Asia over there. And the one over there on the left, that's the long-billed vulture. And the one on the right is the Indian white-backed vulture. Okay, now you probably don't think real highly of vultures. You probably think, they're gross, nasty birds, and they do eat dead carcasses, but they are providing us with a very important ecosystem service. And hopefully you've already listened to the story that was part of the assignment for this week and you heard some about that. Now, historically, these vulture species ranged across Asia, and now they are on the verge of extinction. So why are they on the verge of extinction? And more importantly, why should we care? And this is, again, a really good example. So these vultures, let me go back a minute here. These vultures live in an area where people raise a lot of cattle. And what happens is when the cattle die, a lot of the people will just drag them off or put them in a landfill. And what these vultures do is they actually eat these dead carcasses. And so they're helping keep a lot of smell down, a lot of disease from being passed around by the flies that are eating them, and all this stuff. So they're providing a really important service, getting rid of those dead carcasses. Well, as technology and medicine progressed, we were able to come up with a drug called diclofenac. And it's basically an anti-inflammatory drug that they give to older cattle to help relieve the pain of arthritis and just old age in general. Well, it turns out that this diclofenac, when it gets into the cattle, even after they die, it's still in their system. And so if an old cattle dies and that farmer or that cattle hand, drags the carcass out to the local dump, which is what they do there, and then the carcasses just sit there and they rot and they stink. Well, along come the vultures and they eat these dead carcasses of these cows. So again, they're providing important service. But it turned out that they were also ingesting the diclofenac that was built up in the bodies, in the bloodstream, in the tissues. And it turns out that while diclofenac was really good for cattle, in birds, particularly these vultures, it caused renal failure. In other words, their kidneys stopped working. And it ended up killing them. So the vultures suddenly started having these major die-offs, and their populations plummeted extremely quickly. It was one of the fastest documented declines of species that we'd ever seen in the world. And they went down really, really fast. In just 12 years, they lost almost 97% of both of the populations of those vultures. So, what was the consequence of this? Well, again, those vultures were providing an ecosystem service of consumption and recycling of the cow carcasses that were left at those dump sites. So, one, you got really bad stink going around because it smells really bad. You got flies coming around. But now you also have a food source. Okay, there were so few vultures that the few feral dogs that were around were like, well, sweet, it's an all you can eat smorgasbord. The vultures aren't here scaring us off, so we're going to come in, and they started eating the carcasses of the cattle. Now, diclofenac didn't affect them because they're a mammal. It didn't really cause renal failure in them. Instead, it gave them a food source where they could survive and they could continue to live and reproduce. And so, before we knew it, populations of feral dogs started growing like crazy and taking over these East Indian towns. Well, these guys are not pets. They are not inoculated for any diseases. And one of the major diseases that feral dogs carry is rabies. So the next thing we see is a major increase in the incidence of rabies in humans in these areas because these feral dogs are biting people because there's so many of them. They get really, not scared of people and they start biting them and they're transmitting rabies. So, as a result, humans ended up being the ones suffering because we gave drugs to the cattle, not realizing all the major consequences of it. This is one of the reasons why we need to care, why we need to protect biodiversity and understand all those major cycles and realize how everything impacts everything else. These pictures here, you can see a picture at the bottom on the right. There's some people hanging out on the street with some feral dogs just hanging out. There's a feral dog up there in the right-hand corner. And that picture up in the upper left-hand corner is hard to tell, but it's basically one of the local dumps with cattle carcasses laying around and all the feral dogs around a carcass eating. I'm not sure if this link still works. It was a story done by the Smithsonian Magazine, but if you're interested in learning more about it, you can try that link and see if they still have that story available, that article for you to read. All right, so we're going to do one more video because it's too long to cram into this video, and we're going to go over the term hippo. I am not talking about a large gray animal that lives in the water in Africa. It is an acronym for the actual threats to biodiversity, so we'll finish up with one more video, and then we'll be moving on to week 8.